In problem number 1 on the worksheet, you're asked to find the average atomic mass for a sample of cesium that is 75% 133 cesium, 20% 132 cesium, and 5% 134 cesium. So what we're going to do is actually very simple. To figure out the average atomic mass, we have to first convert these percentages to decimal points and then multiply those decimal points by the isotope mass number. So for 75% 133 cesium, we're going to take 0.75 because that is 75% written as a decimal, and multiply it times the mass of that isotope, which is 133. Multiplying 0.75 times 133 gives us 99.75. So for the next part of our problem, we're looking at cesium 132. Now there's 20% of cesium 132 in our sample. So first step is we're going to change 20% to a decimal, and so all we're doing is moving the decimal over twice, and that becomes 0.20 times, since it's 132 cesium, we're multiplying it by 132. Multiplying those together gives you a value of 26.4. And now we're ready for our last isotope, which is 132 cesium. I'm sorry, 134 cesium. 134 cesium at 5% is going to give us 0.05 times 134. Multiplying those values together gives us 6.7. So this value here is the average, not the average atomic mass, but the atomic mass for each one of the samples for our isotopes. Now remember, if we're talking about mass, our units are always going to be atomic mass units, or AMU. So to get our final total mass for this sample, we simply have to add up these values. And so if we add 99.75, 26.4, and 6.7 AMUs, our total, or our average atomic mass, is going to be equal to 132.85 AMU. And so that is our final answer. That is our average atomic mass after we've taken into account the relative abundances of each isotope.